Hello? Hello? Hello, is anyone there?
Hello. Hi, yes, Ome, I am here. And Dom, hi. I see the two of
Ah,
you are here. Thank you very much for joining.
good afternoon.
Dom, I see you're in here twice now. Is
Oh,
that just a weird thing on my side, or are you dialing in from two different machines?
no, I got cut off. So I logged in
Ah,
again.
okay.
I'm sorry about that.
No problem. I'm pretty sure the other one will sort itself out in a second. Let me just see where everybody else is. I am expecting two more people from our community who were people who had indicated that they wanted to participate. Hello, Sandy. Ah, and Foley. Foley, I was
Hello.
about to ping you. Hi there.
Hello.
Let me check in with Festus, who also wanted to join our session today. Alrighty. I did ping Festus, so we'll see if Festus is able to make it. What I'm going to do is just call up our discussion. I'm going to take sort of notes in the discussion as we go. But this is our kickoff meeting, and largely the intention of the kickoff meeting is to get this working group started and to formulate our problem statement and our objectives and outcomes and what we want to be able to achieve. I would also um, like to check in if we can elect a lead for this work stream, and specifically a lead who is not me. I have views around what we should be doing, but I don't want to be the person who makes all the decisions. I also would like this to be more of a community-oriented and community-led activity specifically. This is going to be our first working group under the auspices of the Tazama Technical Steering Committee, where, as part of our community-led pivot and focus for new development and working groups. So I'm quite happy to take the minutes and make all of the notes in the session, which I know is a job that nobody else really likes either. So, and that would be my way of compensating for not actually coordinating anything and doing any of the real work. So if you'll forgive me, I would very much like to hand over the baton to somebody else. So we'll get to that sometime during the course of our discussion here. And let me just get through all of the bugs that we have logged as part of our beta testing program, which again, I would like to reiterate and welcome everybody to attend. Okay, we are looking for... Why can I not see this? It should be in here somewhere.
Just so you're looking for the working group.
I know it's in the technical steering committee meeting. It's not
Yes.
in the... Yes, thank you. I've made this mistake once already. You'd think I would have learned from the first time. Okay, right. So maybe just a little bit of background for everybody, and I'm going to use this as illustration here. So we currently have a number of existing repositories here. And if you do a search on Helm on the repositories, you will get to see the entire list. So there is a separate repository for DigitalOcean, for EKS, which is AWS, GKE, which is Google, AKS, which is Azure. And then there was a initial attempt on our side to try and establish a generic approach that would cover any of the platforms to try and be a little bit more cloud agnostic. And then we also have a separate on-premises Helm. And if we pick one of these, probably the most mature one, ooh, I don't know which one that would be. I think Foley, your team last worked on the Google Cloud platform.
Sounds about
Do you
right, yeah.
know? Yeah. So this one is probably the one that has the most recent accurate activity. And then it comes with an installation guide that is effectively sort of like 4 steps. But if I remember, this README is several pages long and involves a lot of sort of manual steps along the way, commands that somebody needs to install, things that needs to happen off Helm charts, and so on. This is, I must admit, also not an area that I have specific expertise in, but you can see here components, Grafana, Prometheus. Keycloak is optional, which in a standard deployment probably shouldn't be. ArangoDB is no longer our database, so there's definitely these things have probably not been updated since we moved to Tazama release 3, which is when we dropped ArangoDB from our stack. It's now Postgres. So there's a whole lot of things happening here that probably needs review. This is also, I think, an opportunity for us to restructure this in a way that is slightly more modern and reflective of some of the other open source tools. So I did add here that currently there is a Jenkins app that had been deployed in one of our repositories. Whether or not this app is still relevant here is an open question. This was installed 3 years ago. It's only in one of our organizations. Tazama currently has 2 organizations, so whether or not this is actually still relevant is also an open question for us. So for me, just in terms of our overall objectives, I don't know if anybody has anything in particular that they want to add here, but I feel like we almost have carte blanche at the moment to be able to come up with something that is going to be useful. We can modify what already exists. I don't know if that's going to be easier or not. I think out of everybody in the call at the moment, Foley, you are the only team who've actually successfully used any of these charts. Is that right? I don't think anybody else has. And I see your hand is up.
Yes, I wanted to just ask the problem statement. Should we really try and update the existing stuff, or can we not just make new ones for Tazama 4.0? And then deprecate all of those ones and make a new Helm chart repository? Because I'm not sure what the value is of updating all the old ones, and because the whole thing is we want to make new one repository that works for everything. We do not want to update the GKE, AKS, AWS, all of these acronyms. We don't want to update all of them. We want to make one new one that works for all.
That sounds good to me. So also like there's a opportunity for consolidation here. So regardless of what happens, I would like to see consolidation anyway. Whether we are refreshing or making them completely new, I would love to see only one when we are done. Any other objectives here? Like from the floor. I want to double check the problem statement here, so I'm sort of on Foley's page here. Is everybody comfortable with the problem statement?
I have a comment to make.
Yes,
Hello?
Omer. Yes, hi.
So if we just have one repository for most of these cloud platforms, what are the chances that it will be effective? Would there be need for us to have maybe some tweaks to each of it, or I don't really understand what the focus should be, because I'm thinking that if we have one repository for all of the cloud platforms, which have their own unique configurations, is going to be a problem. And that's my own perspective. Yeah.
So that is also a good observation here, and I think something that we definitely need to talk about, because there are two phases to every deployment, right? The first phase is infrastructure provisioning. And infrastructure provisioning is where the bulk of the cloud platform variation comes in, because different cloud platforms have different permissions you need to set up, different servers that you need to requisition. They have different scripting methodologies. There's a whole lot of platform differences wrapped up in the infrastructure piece. And then there is also the access methodologies for each of those platforms are subtly different, right? And that is what let's call that the infrastructure as code phase. After the infrastructure as code phase, you then have the deployment of the software phase. And the deployment of the software phase then uses your provisioned infrastructure and puts the system on top of that, but requires or expects a Kubernetes substrate at the very least. And once you have your Kubernetes substrate in place, the deployment becomes a lot more generic. It's my expectation that you should be able to parameterize your deployment for the differences that do exist, and then be able to drive those parameters from external, sort of, maybe let's call them YAML files for lack of a better description, because I don't know what it's going to look like at the end of the day. But you should be able to set up the parameters separately and then feed them into what is effectively a standard deployment approach, as long as your Kubernetes substrate exists. I want to, and sorry, Foley, I need to rely on you quite heavily for this because you have the most experience in this area, but is that sort of an accurate assessment of the overall approach and what we could hope for?
You are correct in saying it is actually two separate things, because environment provisioning is not the same as deploying Tazama. So Helm charts are very good at deploying Tazama, but it is terrible at provisioning your environment. So the environment provisioning or infrastructure as code, I would sort of see as a separate deliverable to deploying Tazama. So we can make it one of the problems, but one of the two can succeed and the other one can fail, and the one would still be useful even though the other one is not there.
Right. So the question I have, maybe just as just before I continue, Omer, does that answer the question? Does that give you the clarity you were looking for?
Not quite, but I wasn't looking for clarity anyway. I was just trying to make an observation, because
Okay.
you know, in 010 we have 010 cloud, and then we are powering a lot of businesses, and I have first-hand knowledge of how these things work. Each cloud platform have their own configurations, and when you try, just like you explained, what you explained is actually exactly how it works. So once you try to have one file or whatever it is for all these multiple cloud platforms configurations, it's actually a problem from our own end. It has been a problem. So what we do is we have separate configs for each cloud platform we want to work with. So it's just an observation, not actually a question on my end.
And I think that's accurate. The question I have is for you as the audience is what should we do with the infrastructure at a provisioning piece as it relates to our scope and our objectives, right? Because ultimately, if we are saying that, as Foley suggested, we separate the two things, they are two separate things, right? The second one, which is the one that we would want to work on here, which is the deployment of Tazama, depends on the first one, right? So we do want to at least be able to tell people what that first one must look like so that they can achieve a successful deployment of Tazama. And we don't want to put them into a position where they need to troubleshoot their infrastructure deployment first before they can deploy Tazama. We want to tell them what that end state should look like, right? What is the starting point for the process? And I think in our past conversations, we had a lot of debate around this because, as you point out, I mean, every cloud provider has its own idiosyncrasies and they have their own variables and parameters and approach and deployment and everything else. We don't necessarily want to be in the business where we cater for the overwhelming variety of cloud platform deployment. Making it even worse is you will have different infrastructure deployment options for different performance requirements for Tazama. So if I am going to be deploying Tazama to handle 1 to 2 transactions per second, I need a very different setup than I would if I wanted to deploy Tazama to handle 3,000 transactions per second. So, and I don't want to necessarily be responsible for having to tell people how to configure their infrastructure in the entire continuum between 1 transaction per second and 3,000 transactions per second. That level of variation sounds like it's too much heavy lifting on the Tazama project's side. So where do we feel that infrastructure conversation should take place in relation to the software deployment piece?
Hi, Dom here. Yeah, it's actually quite enlightening to me to hear that. Okay, it's actually divided uh, into two parts. Because the at least on our end, I'd gotten I'd gotten the I'd gotten the infrastructure pieces running on our self-hosted Kubernetes. Where I did get tripped up was all the was all the Jenkins requirements. Yeah. So then, interestingly, there was one other fellow in the Slack group. His name was Hamda, who said that he had got it running. So I gave him PM and asked him, how did you do it? So on his part, he deployed everything via. I think he took it off the Docker images and just simply deployed it off of that. So yeah, I mean that sort of highlights the differing approaches. Where how people would then pick it up from what's existing documentation. Yeah, that's so
Right.
that's item one for me. But the second item was that if you, just as you mentioned about the talking about the scale. I think for me, what's important is having a reference implementation, and just fencing off, like saying, okay, it's probably good up to this much, and then anything bigger than that, for much larger scale, becomes an architectural document. Yeah, my two
So
cents. Yeah.
I'm like, there's a almost a philosophical challenge for me here because we delivered the full stack, right? Which is, I'm going to put it on the screen here because then it'll also end up in our recording, right? So the full stack Docker-Tazama lives over here. And we originally developed this because we needed some way to deploy the platform for ourselves on local to be able to do integration testing and everything else ahead of releases. And we didn't have an easy way to do that. So we built the full stack to do that. And then very soon, the full stack became the default way in which people explored Tazama because it was actually a really easy way to deploy the system. You could literally, it's almost now down to single click deployment, right? I can deploy the entire platform on my local machine as long as I have my Docker environment up and running. If it's a Windows machine, I need Docker desktop. If it's a Linux machine, it works even more simply, right? So all of this works really, really easy, but the ease with which we are able to deploy the system with the full stack Docker Tazama approach almost creates the impression that that is how Tazama should be deployed. And here is where I almost feel like, yes, we have made it really easy for people to deploy the system and explore it, especially in a sort of a single instance environment. But if you really want to deploy Tazama for high scale production, you shouldn't do it this way at all. I mean, that's one of the reasons why we have these disclaimers here, because people have been using this in the production context exactly the way that we have provided it. And that makes me incredibly nervous, because what you are missing is redundancy, you're missing scaling, you're missing clustering, you're missing a whole lot of additional ways in which you can deploy the system. We don't even talk about, how to set up your pods, or, which of your components here are going to be the most hungry for resources that you should make sure runs on, the more of the lion's share of the infrastructure, right? So this makes it a lot easier to deploy, but what we want to be able to achieve with our working group today is to say, how can we leverage the containers that are being used here in a more production grade kind of context, right? How can we implement this to leverage better scaling, clustering, make better use of your pods, more efficient use of your high scale resources? I feel like I distracted myself a little bit here, but that for me is just the big difference. So it would be useful if we could leverage some of the learnings from here, and then make the deployment of a fully cloud-based distributed deployment of Tazama as easy as this. Because even now here, if you look into our dev branch, which is the version that we are currently working on for the release, you'll see Tazama now has 3 very distinct component groups. The core engine is what the full stack used to look like, which is basically just the core engine of all its components, the APIs that then perform an evaluation for you and produces an evaluation result. But in addition to that, we now have the extensions component, which comes with additional Docker Compose files that deploy the case management system and all of the tools that go with it. And then there's the BIAR, which comes with yet another section of Docker Compose files, which allows you to deploy the data lakehouse and all of its components. And then all of this is documented here. As far as a reference deployment is concerned, what we have elected to do was to actually pilot this in the full stack context with an AWS deployment. Because what we needed to do was to deploy we've lost Ome. Hopefully he comes back. What we need to do is to deploy a sandbox that we wanted to use for beta testing. So we also needed to deploy stuff that we could test, integration testing, acceptance testing, and so on. But the system is now too big to realistically run on a desktop. In particular, the data lakehouse component actually has quite a heavy footprint. Out of the 3 servers that we had to provision, the data lakehouse is by far the biggest of the 3. So this no longer runs on local. I can run the core and I can run the extensions on local, but now we basically have to deploy it into a cloud environment just to be able to get it to run. I'm very happy to say that that cloud environment currently runs at about $400 a month and is able to achieve a throughput of about 50 transactions a second, which I'm very, very happy about. But all of these containers are still single instance containers. It's still just the full stack transposed into a cloud environment. It is not, in my mind, a true cloud deployment with scaling and automated, hardware provisioning and clustering and all of those kind of things. But if you did want to try this in AWS, you can follow this guide here. And then we used OpenTofu to do the infrastructure as code piece. And the scripts are in here as well. I would almost I very hesitantly want to call that a reference deployment. So if you did want to try this out in cloud, then you can, but it's not the deployment that we would necessarily want. However, I think you do raise a valuable point. So let's say, for example, that people can use whatever cloud provider they wanted, but if they wanted to see how we did it, we could show them how we do it in AWS, for example. So how do we provision the infrastructure? What servers do we put together for let's pick a number, right? A distributed deployment properly deployed for 100 transactions a second into AWS. How did we do that? What scripts do we have in place? What infrastructure as code did we utilize? And if somebody then wants to transpose that to a different cloud provider, they can use our reference deployment documentation to do that. Does that sort of head into the direction that you were hoping for when you mentioned reference deployment?
Yes, okay, and in fact, what you've mentioned raises an interesting thing. I mean, for me, the question is, what were those architectural decisions, or what are those architectural decisions that you need to take for you to be able to satisfy, like, okay, this is what we need in order to be able to scale. Like, if I'm just looking at the infrastructure component, and I'm fairly new to Kubernetes and all that. Okay, but for instance, the main thing that I could see on the base infrastructure was, how's this Postgres seems to be the one key potential bottleneck here, right? So at least if I'm looking at the Helm instructions. Okay, it's basically based on a single instance of Postgres running on running also in Kubernetes, which may not be the decision a team might make. Right, they might actually decide to run it on some cloud SQL or something. So that's one aspect. But interestingly, the other aspects are what needs does the TMS need to scale, for instance? Is it about scaling the event director? Yeah. So those are the things I'd be interested to look at, because as you said, you have some sort of a reference you have a reference implementation in AWS, but you don't feel very comfortable saying that, hey, this is production. So stepping back and saying, what is it that makes you uncomfortable about saying that this is not not a reference. I mean, it's not production ready. It's basically it.
Fali, your thoughts?
You are making use of software, which is the cloud software, and then you're making use of. How did you guys deploy it in AWS? Did you still make use of Kubernetes, or how did you?
No, so there's no Kubernetes in that deployment at all, I think. So let me let me show you.
Servers. I think I've seen some stuff which made me thought that it was literal servers that you've commissioned, and then on those servers you literally install Docker.
Yeah, so it is essentially the full stack that you would run on a local network directly on a a computer, like whether it is, it's inside a Docker environment, and you are basically just deploying all of these containers directly inside Docker. So this is server A, and it runs all of the core components, and this is server B, and server B runs all of the extension components, and then server C runs all of the server C components. So at the moment, there is no Kubernetes involved.
And with that said, that means you've got no observability, you've got no auditability, you've got nothing.
Sort of. I mean, but yes, not in a way that I think is particularly useful, right? So sure, you can have the observability that comes with AWS's console, right? You can install some of those console things. You have the observability of sort of the console logging, so everything that happens can be logged to console. So we do have some capability here to at least troubleshoot issues when, container falls over or stuff like that. There's also some logs in AWS itself. So for example, we had an issue on server B where we were constantly utilizing the server over the burst capacity threshold. And eventually AWS throttled our server to the point where it was unusable. So we actually had to relax some of our environment settings to be able to use that server effectively. So we were able to do that, but I think you are correct that we are not achieving what we would like to achieve in a production context where an administrator wants to be able to understand the health of the system at a glance. That, I think, is something that you would only get through like Kubernetes. Or if we included any additional tooling, but as you may have noticed, we are not even currently deploying the elk stack here. So that's something that's also probably due for a review at some point in the future working group, is how do we achieve better reporting and application performance monitoring in the system beyond its current capabilities. So yes, you are correct. It's just a Docker deployment of the system across 3 servers.
Yeah, and I think that highlights the problem, if I can put it that way, Dom, is that you are not able to perform any efficient monitoring. You're not performing anything that you would want in a normal production environment. Because you're using containerization, but you're using a software meant for developers on their local machines. And I'm pretty sure a lot of the tools that, I'm not sure what flavor of Dockerization tool you installed, but those tools mostly say that this is meant for developer machines. It's not meant for production use, simply because it lacks the features that something like a full-fledged Kubernetes deployment has. So,
and it's basically, we don't even deploy Docker here. We use the Docker that comes with this. It's built into the server package, effectively.
I see. And is that like production grade according to Amazon?
I don't know. It doesn't make me comfortable.
Yeah, so typically the clouds will have these different functionalities, and whichever cloud environment you will have some sort of a similar setup. But in most of those cases, they advise you not to use it for production because they've also got the Kubernetes instances that they would prefer you use because it's meant for production use. So you've got observability and monitoring and fail-safing and scaling and all of those type of actions. Because in this case, if Tazama wanted to scale, they would have to commission a new server, manually decide which containers they're moving to this server, instead of just saying, here's extra hardware and Kubernetes decide what needs to go where. So it's a very manual process to do anything with the current setup. Sorry, Dom, that was a very roundabout way of getting to an answer, but I'm not sure if I even answered your...
Yeah, it's okay. It's Yeah, it's hitting several points, and I can feel it there. I have a okay. I probably can't consolidate the thought now, but I do get the point. So thank you very much, Johan and Justus. I'm sorry, and taking off from that, where I did hit some problems when I was trying to follow the instructions on the on-prem Helm instructions was on the Jenkins deployment stuff, which I also don't see in I did not see in Docker. So I guess taking the opportunity to ask you guys here, how important was it to use the Jenkins components to deploy Tazama?
Does anybody on this call actually know Jenkins well enough to give us a quick summary of what it actually supposed to do? Because I'm not entirely
Yes.
sure I do, and I'm not confident I can tell you.
So the short answer was, back in those days, when those things were built 2 or 3 or 4 years ago, we did not have a image repository. So Tazama was not, as soon as something as new code comes in, you build the image, and then the image anyone can pull to your local machine. Back in those days, you needed to take the code and build your own image, and then take that image into your Kubernetes instance or your Docker instance in your containerized environment. So you had to build your own containers, because back then there wasn't a repository where the containers lived. So since then, Tazama has now built their own, has their Docker Hub environment, where when the new release comes, this RC, Tazama 4.0 RC, is built to the Docker Hub. So now anyone that wants to install this Tazama can simply pull the already built images from Docker Hub. So now the need for Jenkins is not there anymore. But if you are serious about Tazama in your own environment and you want to do some changes to things, for example, what we've had to do at Cybrin in the past is we, even for some of the solutions or client environments, we still set up the Jenkins job so that we can pull the Tazama code, do some required changes for the customer, and build the images and publish them to the client environment. So for production, you might still want to be able to build your own containers and not just use the ones that's available on Docker Hub.
And to be fair, I mean, the publishing of our containers on Docker Hub is a sort of a, how to put it, a quality of life upgrade for us as well, because it's easier to deploy things and test them. One of the things that we really struggled with was the distribution of our rule processors, because the rule processor is baked as a combination of the rule executor and the rule module. And the code that we have in GitHub for the rule executor only has one rule module in it by default. So if you want to replicate that process 33 times, we used to have to do that manually. So we pre-building all of those containers and publishing them on Docker Hub was a big quality of life upgrade for us as well, just as a way to deploy the platform. But I think those containers probably need some hardening, if I'm honest. We haven't put them through like a full security audit or anything like that. I think Foley is correct. If you have specific security requirements as well, or some protocols that you need to add to your images, then you might want to build your own images. So partly for modification, partly to conform your images to your own environment's protocols, you might have to do that. But here's an interesting thing for me is in both of those instances, you are probably not going to use our Jenkins program or scripting to build our containers in your environment. You're probably going to use your own or create new ones, or modify ours because you're in the process of modifying the source code for a customized deployment anyway. So I think Jenkins probably still has a role to play, but my question is whether or not it should still be Jenkins, because Jenkins at this point is basically the grandfather of scripted deployments. There are other opportunities and options now. Do we want to create an objective to evaluate those, or do we want to stick with Jenkins? And do we still need it for a basic deployment, or is the implementation or the use of Jenkins a stretch goal for helping people customize their deployments? How do we feel?
I don't know really how to put this. I'm just going to let the words go. I would not suggest to take images built to a Docker Hub environment and pull them as is into your production environment.
I'm
So
inclined to agree with you, as even as the person who created all of those in Docker Hub. I feel like you are relying on somebody else's due diligence. And as much as I would like to believe that we are very diligent, you should maybe do your own.
yes. So that said, that means if someone wants to take something live, they need a means to get code into containers. And that means
Yes.
currently is Jenkins. And I'm pretty sure the Jenkins jobs, just as old as they are, would very likely still just work if you were to run those things and deploy the Jenkins scripts as they are right now. So yes, I think there is a need for it. But that's now the first branch that we would have in the Helm charts that don't exist yet, because you can still make use of Helm to deploy the as-is Tazama with
Yes.
the images pre-built. And then you would like another Helm, which is for your fully fledged Tazama DevOps CI/CD pipeline on your local or on your development environment or whatever it is, where it will also include the Jenkins and set it up for you.
Is that the kind of branching that requires different repositories, or is it basically switching inside the one repo but adding a lot of complexity?
Yes, to both. So yes, you can make it optional and make it switches and whatnot. You can make use of flags in your Helm chart, and when you deploy, I can say Helm deploy, or I can say Helm deploy -- with Jenkins, or something like that. And then
Right.
your deployment will install the Jenkins. But then, yes, as you mentioned, the Helm charts will then have some additional things which people will see, and it doesn't matter if it's there or not. But it will be slightly more complex because for your Jenkins, it will have the code to actually deploy Jenkins, and it will have code for the to get the latest scripts and do that.
Sorry, Foley, your microphone just dipped out.
Sorry, I'll be right back.
Something's happening. Give Foley a second, but I'm going to add these two here as maybe to a sub-objective. So sure, we can develop a deployment approach for Tazama on a Kubernetes substrate, but that could be with Jenkins, and that means building your own images, and that can be without Jenkins, and that is using the published Docker Hub images. I'm not too sure what the order of these would necessarily be, but it sounds like they would both be very similar anyway. It's just a question of at some point you are defining the source of your container. So
Sorry,
if you can do it with Jenkins, you can probably easily do it without Jenkins on the same.
Yeah, in most cases, why would I be using, what is it that I would be building? Is it the rule containers? Is that okay? Are those the images that I would be building most often, or does that also include the other components like the TMS and the event director and a few of the other things?
I would almost say that if you are choosing to build your own containers, you're probably going to be doing all of them, but maybe with a caveat. So if I read between the lines of your question, we currently have a number of prefabbed rule processors for you. There are 33 rule processors immediately available for you to use. We do anticipate that rule processors, and to some extent, maybe the transaction monitoring service, will be the two components or the two types of components in your deployment that will always be customized. You will always need either different rule processors or new rule processors, so you are always going to be building rule processors somewhere. And if you are building your own rule processors, you are not going to benefit from publishing them to our Docker Hub to be able to deploy them. You can, I suppose, publish them to your own Docker Hub and then use the images from there. But I think that becomes a question of your development cycle or your development approach, right? Do you publish your things internally in your company to Docker Hub and then move from there? Or do you go straight from source code into deployment, and then you would need something like Jenkins, or you would need to build your own containers? So I think it depends on your internal development cycle, and specifically for the components that are likely to see a high turnover of change, which would be the rule processors themselves and the transaction monitoring service, if you want to add additional hard-coded data pipelines to the interface.
Right, I got it. Thank you.
If
Okay.
you don't want to make use of the rule studio.
Yes. And that's an extension here, but the rule studio itself, that I almost want to descope, because the rule studio does publish actual rule repositories to your own private organization in theory. We're still busy testing that and trying to wrap our head around the capabilities and the opportunities there. But you will still get a GitHub repo that contains the source code for your rule module. That rule module needs to be baked into a rule processor combined with the Tazama rule executor, and that then needs to be deployed. So the Rule Studio does come with some workflow for that CI/CD and that deployment, but that almost functions separately. I'm not sure if they go straight from source code to image, or if they go from source code to Docker Hub and then from Docker Hub to deployment. I would almost want to say that that becomes a separate exercise for us. We need to consider that separately. So is everybody comfortable that we descope that as part of this initial deployment as a separate thing? And then we can come back to it later.
Yeah, makes sense to me. So as a FYI, what we've done is for the rule builder that we've built, we made it call a Jenkins job. And it would basically create the repo for the code, and then it would give that repo to the code to a Jenkins job. And then Jenkins would build the image, publish it to a repository of your choice, and then carry on. So,
which is fine. I mean, that's almost the process
that
we're intending to build here. So it'll be with Jenkins, build your own images, and you just point it at the source code.
Yeah,
makes sense. Yeah. Okay, perfect. You'll see I left Foley, so I skipped ahead a little bit based on what you were saying before you had to dash off. But essentially, we are developing a deployment approach for Tazama on a Kubernetes substrate, either with Jenkins, which means build your own images, and without Jenkins, which means using the published Docker Hub images. And I almost want to say these are the Tazama ones, or in theory, could be your own. So if you have pre-published your own images somewhere, you could typically deploy those. And I can see that possibly as an opportunity for somebody who wants to create rule packs that they want to keep, that they want to resell, right? So if I have a set of rules that I want to be able to use to evaluate, for example, Mojaloop traffic, then I can pre-publish these on a private Docker hub somewhere, and I can deploy them from there and maintain them on everybody's behalf, I guess. I mean, that could work. So not necessarily the Tazama ones, but publish Docker Hub images somewhere. But either way, those will be fine. Is that more or less okay? Is that an acceptable objective for us for today, or for the working group? Do we want to add more to that in particular? And you'll see I left a line open over here because I still have an unanswered question.
Yeah, I think so. So just thinking of what Festus was also asking for, this would answer his question because I think he was asking for how to deploy, well, Helm-charts to deploy Tazama. So I think
Yes.
the only complexity that I foresee is the split, to say with or without Jenkins. So yes, I think that's a good addition. And then the other piece that comes with is the infrastructure as code, which I almost want to deprioritize
Yes,
and make a different thing altogether.
Right. So I think that's maybe we have a few minutes left before the end of our workshop today. So I think maybe that's something that we should then debate, because that's the line 3 that I left open over here. I would like to offer Dom's suggestion as a compromise. If we can come up with a reference infrastructure deployment that says, we're not going to tell everybody how to do this on every provider. We are going to show you what it looks like in AWS. And then you can use that as sort of a template or an example of doing this in your own environment. So can we, as part of this process, come up with some sort of baseline example deployment on AWS as a prerequisite for the Tazama software deployment onto that infrastructure? Is that something that we can contain as a viable outcome? So not solving for every cloud, but just trying to do this in one, as an example.
Once you have the example for the first person that uses Google, DigitalOcean, or whatever else is going to ask, okay, so how do I do it in here? So I'm wondering what the value is of showing the example.
Because it'll at least give them a point of departure. So I take your point, right? So it's not necessarily going to be the same, right? But what it would show them is you can, out of that particular infrastructure, I can dump the infrastructure plan in OpenTofu, right? And then somebody who knows their way around it can modify that in OpenTofu, and then use that to provision the infrastructure on their chosen cloud provider as well, I'm assuming, right? So at least it gives somebody something, because at the moment you are asking people to put together infrastructure with absolutely no context whatsoever. They have to guess at this point. We have nothing that we can tell them.
Yeah, so I think that's sort of answering my question. What would be valuable is instead having a table of saying, for X TPS, this is sort of the hardware that should satisfy your need. So that's why I linked in the chat. Yes.
Yeah.
So that sort of, I think, answers the question for me.
Right. Is so what I'm missing is, and this is only based on my own very, very limited experience now of deploying Tazama into sort of a AWS environment, even as just basic containerized, is we don't tell people about load balancing, right? So you have to provision load balancers. You don't tell people about, the methods of interaction. We're just giving them a hardware specification. We're also not telling them about the distribution of pods. We're not telling them about, how to cluster the database properly. None of those things comes with a infrastructure spec sheet, right? It doesn't give them the how. Ome?
Hello. Okay, so
Yes.
I have a suggestion. Basically in the cloud, every VPS is just the same. The difference is just maybe various companies' value propositions to their customers. So VPS, dedicated servers, metals, bare metals are the same. So if we can come up with a solution for a standard VPS, a standard dedicated server, and a standard bare metal, this should work for any cloud provider. Now, any expert who is working with, let's say, take for instance, AWS, should be able to know how to tweak the standard to their environment. Likewise, Google Cloud, Azure, and the rest. So that's just my own suggestion. Thank you.
I mean, for me, that actually relates to what I was also angling for, because if you at least give somebody at one, right, that they can use as an example, it gives them a bit of a starting point. It's I think it's very difficult, and maybe it's for me because this is not something that I do every day, right? But let's say, for example, I had access to a team of technical people and I can tell them, listen, we're about to deploy this Tazama thing, and it needs this kind of infrastructure. You DevOps guys, you infrastructure guys, you go out and you figure out how to make it work, right? Those guys can do that from scratch. My experience, for example, during our performance benchmarking was that turned out to not be such an exact science. There was a lot of trial and error involved in that process, right? And we ultimately had to move that process onto on-prem first so that we can do all of our exploration on premises, and then we had to transpose that process onto cloud so that we can proof our benchmarking in the cloud. But I remember that process was it wasn't very straightforward, right? There was no definitive answer on the infrastructure composition. And I wonder if we don't help some people with a starting point, then we're going to get more questions in certain instances because people will need to know how to get started. Like basically, what should the hardware look like? How should we compose it? How should we set up the networking between all of these components? Why is this component not talking to that other component that exists in a different subnet or whatever the case is? I don't know. I mean, let me ask the question in a slightly different way. We go 1 minute ago, right? Let's say, for example, we develop this piece here, right? Without this piece over here. How are we going to know that it's working? How are we going to test it ourselves in the working group to know that we are successful if we don't have somewhere to put it? And if we're building somewhere to put it to test it, why can't we just document that as an example to say, we built this here and we tested this here, and that's what that looked like? Because otherwise, how are we going to do it?
So I think my question just came basically from, we've got this documented. We're saying this is what you need to set up a sandbox. This is what you need for 50 TPS. This is what you need for 250 TPS. This is what you need for Tazama that can run 2,500 TPS. So I'm sort of actually asking what do you need on top of that? Because we're back to just saying, what is the hardware require? In those existing
how must it be
documents,
composed? Right.
Yeah,
Because
in that
here's my
existing
challenge,
documents.
right?
Yeah.
And I'm going to put this out here, right? I'm going to go back to here, right? So the Cybrint team developed this, right? At the time that they developed this, nobody else And I say this with the greatest respect to our community, right? Nobody else has been able to make a Helm-based deployment of Tazama work in their environments. The only team who has actually been able to successfully deploy Tazama in Helm that I know of is the Cybrin team, right? And every single time we look at any of these Helm charts, we need to tweak them, we need to fix them, we need to panel beat them to work in a environment. And what I want is I want to be able to confidently say that these Helm charts do work because we have deployed and used them to put Tazama into this environment. So at least there is one instance that we as Tazama can point to and say, yes, we know for a fact it works because we have tried it. At the moment, Tazama as an organization does not have the capability to actually test or deploy Tazama in through Helm. We simply do not. And I don't have the confidence to go to the community and say, yes, all of these are working. Because nobody else who has tried has been able to do it successfully. I absolutely have to have a successful deployment to have confidence that I can tell people that these are working. Does that make sense? I know like I'm being like very honest and talking out of the kitchen here, but at the moment, this is a big problem. We don't have the internal capability to test all of these across all of these different platforms, but at least if we can have one successful deployment setup from start to finish, we can reference, that would be a great win for this.
Right. Yeah. So I think, hoping not to extend this too much, with that successful deployment, is that okay? Would it be permissible to use the Docker Hub images, for instance, because that takes out the complexity of having to build it? And looking at the document that you wrote, this is that it was actually it actually became a separate item, right?
Yeah.
And then the other thing here, sorry, go ahead.
Can I answer that first? Because I don't think it matters, right?
Yeah.
Because in either of those two cases, certainly the test will be simpler if we do it without Jenkins, because that's one extra step we don't have to worry about, right? But for me is the variation between these two options is actually not that great that it would be impacted by our choice of infrastructure. I don't think it matters at that level. So either one of these will be fine, but ultimately we need to develop both of these anyway. And if the infrastructure has been provisioned and it satisfies the requirements of this one, I think by default it will also satisfy the same requirements for that one. There's no difference at that point. The same infrastructure will suffice.
Yeah, but it's simpler to just use the Docker Hub images, although in actual production, you may not want to.
Yeah.
Right? Yeah.
No, of course. But ultimately, that for me is not an infrastructure issue, right? That's just a sort of, if we want to keep on testing and retesting this, at some point, I want to make sure that the Jenkins part works. And then if I'm going to be repeating this often enough, I'm going to do it here because it's faster, right? So I might still want to be able to use the published images just because if I'm retesting and rebuilding and tearing down and rebuilding again, it's going to be quicker with Docker Hub. Building all of these images, they're very time consuming, right? And they don't stick around. Once you've built them and you tear down your environment, next time you need to rebuild them. And it takes a while to compile these. Some of these take an hour to compile. And there are, at the moment, I would guess probably about 50 or 60 different images that you need to build every time from scratch. So for testing repeatability, we're probably going to build them that way anyway. But both of these are objectives of the exercise. And then Dom, you had a follow-up?
Yeah, basically, yeah, my follow-up then was, what's the minimum that would that would then meet the requirement for point number three, which is uh, uh, so yeah. No, because I was sort of thinking like, if you're talking production, we mentioned earlier about having Elasticsearch. I mean, my organization may not necessarily want to use that. I mean, we use a
Yeah.
variation. We use OpenSearch. Yeah. And also,
Yeah.
those are things that you may just say, hand wave like, okay, you need this. So it may not be, OpenSearch may not be part of a minimum. Postgres would be part of the minimum, right?
Yes. Yeah.
Because you do need a database. In actual production, we need to think about the high availability, failover, etc. That's basically tweaking the database. But for a Helm deployment, okay, with a simple Postgres instance with a stateful set, okay, would that be sufficient? I mean, probably yes, right? And the if I'm just basing it off the full stack Docker deployment, having deployed, seeing at least two rules working, being part of the deployment was actually quite helpful. So that's something that I would like to see as well on a Kubernetes Helm deployment.
Okay.
So
I want to pick at one of the things that you said because I think that actually resonates a little bit. So should there be a performance target here for the infrastructure that we're proposing to use? That will be a good example of the complexity that people would experience in a production environment. I think that's probably a worthy objective. At the moment, like I said, with our AWS deployment in the full stack, we were able to achieve, let's say, 50 transactions a second. All right. If you wanted to achieve, for example, 100 transactions per second as a sustained load in that environment, you're probably going to have to do more than a full stack deployment. But you can get away with a full stack deployment up to 50. So if we wanted to pick a performance target here for a reference infrastructure, I would say 100 transactions per second would not be too great and would probably still be reasonably affordable. Because here's the other thing is like the infrastructure, the more performance you require, the more expensive it gets, right? So I mean, we do want to be able to afford testing our solution when we get there. But I don't know if we go with the smallest footprint we probably can think about, what would that look like so that it illustrates the complexity that you would experience in a production environment. We can explore that. Fadi, I see you. I We are 10 minutes over time. We should probably maybe revisit this conversation and maybe everybody could think about it a little bit. But Foley, your question or comment.
Yeah, just a big asterisk next to your 50 FTPS. That's without logging or monitoring or anything at all. So 50
console logging.
TPS, bare metal. Exactly. So 50 FTPS bare metal, if that's the ask, or 100 FTPS bare metal, sure.
Yeah. No, but you're correct, right? We should certainly not be using the full stack deployment as any kind of production reference. It's like we're very clear to tell people that whenever we talk about it. So you may find that you are correct. For us to be able to deploy the system in its full plumage in a production setting, you are going to get less performance for more hardware, at least at the bottom end, and then it's going to scale up from there because you're going to be doing more. You're doing clustering, for example. You're using multiple servers for redundancy, so there is going to be a explosion of hardware to establish the baseline. And again, that for me is why it's important to be able to tell people, listen, if you want to do this properly, this is what it should look like. We can give them the hardware requirements, sure, but I would still like to be able to test it in practice. I would like to be able to confidently say that, yes, it works, and this is what we did, and we can show it. who can prove it. At the moment, I can't. I mean, literally, the only people who have done a successful Helm-based deployment is Cybrin that I know of. Terrifyingly,
we've done it a
everybody
couple of
else is
times.
running it on the full stack. Yes.
Funny enough, I've deployed Tazama 4.0 without.
Yes, so thank you very much. I appreciate you being here. I would like to nominate you to lead this work stream. We can talk about that at the next session. So I will be setting up a follow-up session in a week from now, on Tuesday next week. Same time slot. We're going to try and keep to this time slot on a weekly basis to keep momentum and to build up some sort of regular cadence. So I will be setting that up, and we will see everybody again next week, Tuesday. I really appreciate everybody being here and for your engagement. I'm really looking forward to seeing what we can produce at the end of this. This is very exciting. Thanks, everyone.
Thanks, everybody.
Bye.
Thanks all. Take care. Bye-bye.
Bye.
Bye,
Bye.
everyone.